How often have we all heard that global warming is naturally being caused by the sun? In fact, the other day I saw a video that merely said, "It's the sun, stupid." So this video is going to look into just how stupid it is to blame the sun for global warming. Let's address some scientific principles that we're going to be using throughout this video. First of all, let's consider what makes the Earth hot. The largest single source of energy is incoming light from the sun. That comes in the form of gamma rays, X-rays, extreme ultraviolet, optical light, and radio waves. This makes up about 99.95% of the incoming energy to the Earth, and most of that is in the optical part of the spectrum. Another source of energy is internal energy leaking outwards. The core of the Earth is still molten, and some of that energy leaks out through conduction, although rocks are not very good conductors of heat, so that process is very slow. Much more of it comes out in the form of volcanic eruptions and continental drift and things of that type. We also have a flux of incoming particles. Some of those particles come from the sun in the form of the solar wind. Other ones come from outside the solar system in the form of cosmic rays. While individual particles here have a large amount of energy, there aren't very many of them, so the total flux of energy into the Earth is tiny. Another form of heating is derived from the tidal effects of the sun and the moon. They cause a churning of the oceans and interactions between the land and the oceans, which are both forms of heating. However, the amount of energy involved is tiny by comparison to the energy coming directly from the sun. Now let's take a look at what cools the Earth. First of all, not all the energy that reaches the top of the Earth's atmosphere is absorbed by the surface of the Earth. Much of it is reflected back into space. This is called the albedo effect. Ice and snow has an albedo of 0.9, which means it reflects back 90% of the energy that it receives. Clouds have an albedo of 0.7, so they reflect back 70% of the energy it receives. The land has an albedo of 0.3, so it absorbs 70% of the energy that it receives. And the oceans have an albedo of 0.05, and they absorb 95% of the energy it receives. Now what happens to that energy once it's been absorbed? Well, the oceans, land and atmosphere heat up to different degrees depending on how much of that energy they have absorbed. They then radiate that energy away in order to maintain equilibrium in the infrared part of the spectrum. The way it works is that the warmer something is, the more energy it radiates, and it tends to radiate that at shorter wavelengths. The cooler an object is, the less energy it radiates, and tends to radiate that energy away at longer infrared wavelengths. But in order for it to maintain equilibrium, that outgoing energy must be equal to the incoming energy. And in a warming world, that is not the case. So it's all a matter of balance. For a stable climate, the incoming energy must equal the outgoing energy. Now, over short periods of time, you can have a small imbalance that will either result in warming or cooling of the planet, but over the longer term, those two quantities should be on average equal. For a cooling planet, the incoming energy must be less than the outgoing energy. Now you can do that one in two ways. You can reduce the amount of incoming energy, or you can increase the amount of outgoing energy. Either way, you'll get a cooling effect on the planet. In a warming planet, the incoming energy must be greater than the outgoing energy. Now again, you can do this in one of two ways. You can have more incoming energy, which is what those that are arguing the sun is producing global warming are saying, or you can have less outgoing energy, which is what the climate experts are claiming in the fact that there's more greenhouse gases in the atmosphere, which is preventing some of that outgoing energy from escaping. Now let's discuss what is stable and what is unstable. An example of a stable system would be to have a ball in the bottom of a well, just sitting there. Now, that will remain that way until you do something to it. So that's a stable system, but that sort of system hardly ever exists in nature. The much more common system is what's called a dynamically stable system, where you have the same well and the same ball in the bottom of that well, but you perturb that ball and it will oscillate backwards and forwards around that average stable point. An example of that is the solar cycle. Here we have the total solar radiance of the sun oscillating between relatively narrow limits, but always basically the same average value. You can also have a system where there are several wells or several stable points, and such that if you perturb the system enough, it will go over one of those humps and fall into a new stable configuration. That hump in the middle there is called a tipping point. And that's what we're trying to avoid in the Earth's climate system, is going over a tipping point and find a new equilibrium for the Earth's climate that is less desirable for our type of lifestyle. An example of this already exists in the climate in the cycle between ice ages and interglacial periods. You can see we seem to spend a long time in ice ages and then short periods in these interglacial warm periods like we're in currently. That would say that the Ice Age is a much more stable configuration for the Earth than the warm periods, because they only require a small perturbation to be able to get them to go back into an Ice Age, whereas it requires a lot of time and a lot of perturbation to get from an Ice Age into a warm period. You can have an unstable situation where your system is sitting on the top of a tipping point, and even the slightest perturbation either way will cause runaway heating or runaway cooling, and you have an example of that in Venus. Venus gets about the same amount of energy from the Sun as we do. Even though it is closer to the Sun, it's got a much higher albedo, so the amount of energy that the planet overall absorbs is about the same as the Earth, yet its surface temperature is 300 degrees centigrade warmer than ours. This implies that Venus in its distant past underwent some major perturbation in its conditions on the planet which put it into a runaway heating cycle. Even the most ardent climate skeptics are now admitting that the globe is warming. Just take a look at this map for 2015 and you can see that only 3 pixels on this map have record cold temperatures, whereas there's well over 100 pixels on this map that have record warm temperatures. In the last year we've set 123,000 record highs, while setting only 42,000 record lows. 10 of the last 12 months have set new record highs, and 16 of the last 24 months have set new record highs. Since 2010 we've had the first, second, third and fourth warmest years on record. That would be respectively 2015, 2014, 2010 and 2012. And this trend goes back quite a long way. These are the decadal averages of global temperatures, and you can see that going all the way back to 1950, that the 1960s were warmer than the 50s, the 1970s were warmer than the 60s, the 1980s were warmer than the 70s, the 1990s were warmer than the 80s, the 2000s were warmer than the 1990s, and the 2010s are so far warmer than the 2000s. And that is not including the 2015 figures in this particular plot. So there's more energy coming in than going out if we have a warming planet. So where is that energy coming from? That heating can be caused by one of 3 factors. The sun's energy output is increasing. That's the one that's argued by those that claim the sun is directly causing global warming. More energy is reaching the surface of the Earth. That's the argument used by those that believe cosmic rays are causing global warming. Or less energy is escaping the Earth. This is the argument used by the vast majority of climatologists who believe that the increase in greenhouse gases in the Earth's atmosphere is causing global warming. Or of course, some combination of the 3. In science, we don't just use qualitative suggestions, we have to use numbers. So here again is the total solar radiance of the Sun over the last 40 years. Now for this to be producing global warming, this trend would have to be upwards. But if you look at the data, the trend is anything but upwards. In fact, it's probably down. You can do this with the maxima of the last 4 cycles, or you can do it with the minima of the last 4 cycles. And the trend is the same, slightly downwards. But what would that trend line have to look like if it was to explain global warming over that same period? It would have to look like this. And clearly that is not the case. So you cannot blame increases in the total solar radiance of the Sun to be explaining global warming. It's just not happening. So what is this theory about cosmic rays causing global warming? It goes something like this. A supernova generates cosmic rays. Those cosmic rays suffuse the universe. Some of them reach the solar system. However, the heliosphere diverts most of them away, the heliosphere being the Sun's magnetic shield. However, some do reach Earth, and they are supposed to interact with the Earth's atmosphere, causing showers of particles. Those particles form nucleation centers for clouds. So the stronger the Sun's magnetic field, the fewer cosmic rays will reach Earth. Fewer cosmic rays means fewer clouds, means warmer planet. This is the classic case of a hypothesis that has failed to make it to a theory. There are a number of reasons for that. Let me just go into some of them. The first is the sun's magnetic field is not increasing, which is required in order to make fewer clouds and let more sunlight to the surface of the Earth. We measure the number of cosmic rays hitting the surface of the Earth, and those numbers are not falling. If anything, they're slightly increasing, which would be the wrong sign for the effect. Another problem is that cosmic rays are absorbed very high in the Earth's atmosphere, well above the level at which clouds are formed. So they would have very little effect on those clouds. The CERN tests that have been so often quoted by the proponents of this theory did indeed show that cosmic rays can form these nucleation centers. However, they are far too small for water droplets to adhere to them. And lastly, even if all of that were not true and we had far fewer nucleation centers for clouds to form, then it would make no difference, because at the height that clouds form, there are lots and lots of nucleation centers already. We have dust, we have ashes from meteors, and we have pollen. In fact, the atmosphere at those levels is basically saturated with these particles, so adding a few more would make no difference whatsoever. Well, let's draw some conclusions. Based on the measurements of the total solar irradiance, the output of the sun has not changed enough to explain global warming, or indeed even in the right direction. Also, the modulation of cosmic ray flux by the sun's magnetic field cannot explain global warming either. It seems that the dominant cause of global warming is an increase in greenhouse gases and aerosols in the atmosphere, amplified by a resulting change in atmospheric humidity and also the Earth's albedo. So the next time you see someone claiming that the sun is causing global warming, please post a link to this video and just say to them, it isn't the sun, stupid.